Okay, so here we're going to look at adding and subtracting fractions. But before we do that, we're going to think about what the fraction actually tells us. Because more often than not, people tend to really struggle with adding and subtracting fractions. And it's not because the math's difficult, it's just because they don't understand what the fraction actually means. So if we think about our fraction, it's one number over another number, one number divided by something else. And we might even remember, or we might even know, that the thing on the top is called the numerator, the thing in the bottom called the denominator. Okay, but what does that actually mean in terms of our examples? So here, for example, we've got 2/3. What does that actually tell us? Well, that on the bottom tells us the size. Of the bits. So what that's telling me is I had my one whole thing and I've split it into 3 parts, into thirds. Okay, my number on the top tells us how many bits we've got. So in this case, 2. Okay, so I've got 2 out of 3 bits here. If I look at my next example, I've only just penned over a little bit, I've got 3/5. And so my size, my bits, are fifths. So take my one whole, 1, 2, 3, 4, 5. Okay, and there was the magic of being able to do this as a rectangle rather than a circle. It's much easier to add an extra bit on when you haven't drawn it the right size. So I've got 5 bits there all together, and I want 3 of them. 1, 2, 3. Okay, that's what it is that we want there. That's what this represents. I've got the size, I've got how many. But when we start asking you to add and subtract fractions, we might ask you something like 1/2 plus 1/3. And thinking about cake, okay, something that always splits opinions with mathematicians, so whether you should use that example or not, doesn't really matter. If I've got half a cake, and then I want to add in 1/3 of a cake, how much cake do I actually have? Our problem that we've got here is that the 2 bits I've got are different sizes. And so what we know is we're going to have some cake. But how much cake is the problem? Okay, and what we need to do when we're adding and subtracting our fractions is we need to split these so that they're in the same size chunks. Okay, now we can have more of them, okay, but that doesn't mean that it's going to be worth any different in amount. Okay, and the example we always use is if we've got that same cake, cut it in half, but then I cut it into quarters. All I'm going to do that time is I'm just going to take those 2 bits there. I'm still going to have the same amount of cake, okay, I've just taken more pieces. So when I cut them into 2 bits, I only had to take 1. If I want to cut them into 4 bits, I need to take 2. Okay, that's the idea that we're going to be thinking about when we're looking at doing these. Okay, what I need to find though is I need to find a way of cutting them at the same size bits so that this shape, my half, and my third give me the same size. Okay, and what we can do is we can have a wee think, but what I need is I need a number that's in the 2 and the 3 times table. Okay, so 6 is my answer. And what I'm going to do is I'm going to cut both of these into 6 bits. So there's 6 there. And there's 6 there. And again, what I want is I still want half of it. So I want half there. So if out of 6, I need to have 3 bits. 1, 2, 3. And here, if I want to have 1/3 of it, I'm going to have these 2 bits. So I've got 2 bits out of my 6 altogether. And so what I can actually do is this question here, this 1/2 plus 1/3 is the same. That's 3/6 plus 2/6. And what I've done there is I've used my equivalent fractions to help me. So if we don't really remember our equivalent fractions, we can go back and have a look at that video where we look at equivalent fractions and simplifying fractions. Okay, that's what we've got. Now, I can add them together, because now my size of chunks are the same. Now I've got the same size bits of cake. Okay, that's not going to change. They're still going to be the same size. What is changing is how many I've got. And this one I had 3, that one I've got 2, and so when I add them together, I end up getting 5 bits of cake. So that's just a little bit of theory as to what it is we're doing. Let's do some of these examples. Okay, remember in this bit in the box when we're adding and subtracting fractions, they must have the same denominators. So here, I want to add 1/5 to 2/5. First check, are the denominators the same, the numbers on the bottom? Yes, they are. So I don't have to worry about that. First thing I can do then is write that in. If I've got one of them there, plus 2 of them there, that gives me 3 of them altogether. Okay, so they're my 3/5. The second one, 1/3 plus 1/4. Well, now I've got a similar problem to what I had over here. They're different things. So what I'm going to do is I'm going to use my equivalent fractions. How do I decide what number I'm going to have on the bottom? Well, I need a number that's in both the 3 and the 4 times table. So we're going to make them into 12s. How did I turn that one into 12? Well, 3 times 4 is 12. And so I'm going to have to do 1 times 4 to give me 4 there. 4 what's are 12. 4 3s are 12. So I need to multiply by 3 on the top there, because what we've done is we multiplied that one by 4, that one by 3. And remember in our equivalent fractions, again, check it out if we don't remember, we need to do the same at the top as we've done at the bottom. So I've got my size of chunks the same, so there are 12ths there, there are 12ths there. I can write that in. Size of the chunks isn't going to change. How many of them is going to. So 4 plus 3 gives me 7. Next example I've got then is 1/3 plus 5/3. Same denominator, so I can chuck that in. I've got 1 of them there plus 5 of them there. That gives me 6. So here I've got 6/3. What you're going to be expected to do when you're adding and subtracting is simplify your answer if it can be done. And so what we've got then is if we've got 6/3, that is the same as 2 whole. 6 divided by 3 is 2. Fourth one, what I've got here is I've got a difference in my fraction types. So the first one is 2 1/2, 2 whole and 1/2, plus 3 over 2. So when I'm doing this, I need to make sure that the fractions are of the same type before I can do anything. Okay, so I'm going to make the first one a top-heavy fraction. Okay, again, if you don't remember that, check out the video just before this, just to remind yourself. So if I've got 2 whole, I'm going to have 4/2 plus this other one here is going to give me 5 over 2 plus the 3 over 2 that's already there. My denominators are the same, so my size of chunk is going to be halves. I'm going to be dealing with 2's. And then I want to know how many bits I've got. 5 plus 3 gives me 8. 8 divided by 2 is 4. Okay, I'm going to move over to this side a little bit now, get some more of this done. So example number 5 is 4/7 minus 1 over 7. So when I'm looking at that, my denominators are the same, so I can write the 7 in. If I've got 4 of them here and I take 1 of them away, I'm left with just 3 of them. Okay, so that's all we're looking at. 6, I've got 1/3 minus 1/5. So here I've got the same problem that I had in example number 2 and that I had up there. I've got different denominators. So first thing I'm going to do is I'm going to find out what my equivalent fractions are. So I need a number that is in the 3 and the 5 times table. So 15 appears in the 3 and the 5 times table. So I'm going to deal with them both in terms of 15ths. So I need to multiply that one by 5, multiply that one by 3. So if I've got 5 times as many bits, I need to have 5 times as many bits there. And I've got 3 times as many on that side. So 1 times 5 is 5. 1 times 3 is 3. Denominator is the same now, so I can write my denominator straight in. My size is the 15ths of the shape. If I've got 5 of them here, and I take away 3 of them, that just leaves me with 2 of them. Example 7, I've got 8/3 minus 2/3. So my denominator is the same, so I don't have to bother with this middle step. I can just jump straight to writing in the denominator. I've got 8 of them here, I take 2 of them away, I'm left with 6 of them. So I've got 6/3, that's my answer. Well, what is 6 divided by 3? It's 2, and in fact that actually was the same one as we had up there in question 3, so that one should have been easier enough. Finally, question 8, I've got 3 and 1/3 minus 1/4. So I've got different fraction types here. So the first thing I need to do is I need to make it so that they are the same. So I'm going to change this fraction to be a top-heavy fraction. So I've got 3 3s are 9 plus another 1 gives me 10/3 minus 1/4. Okay, what I've got now is I've got different denominators. So I need to use my equivalent fractions. And I need to find a number in the 3 and the 4 times table. Number in the 3 and the 4 times table is 12. I multiplied that one by 4, that one by 3. So I need to do the same thing to the top as I've done to the bottom. So 4 times 10 is 40, 1 times 3 is 3. So I end up here having 40 twelfths, and I want to take 3 twelfths away. So I've got the denominator the same, I can chuck my 12 in, and then 40 minus 3 is going to give me 37 twelfths. Okay, and unless the question asks for it, you don't have to specify. You can give your answer in whichever form you want. Okay, unless the question says give us a mixed fraction, gives it a top heavy fraction, I would tend just to leave it there like that. Okay, so now that we've done these, you might want to go back through and check out this kind of middle step process. You might want to check out your equivalent fractions again, but hopefully we can understand a little bit more why we need to make the denominators the same and why they don't change. So in every single one of these questions, right, apart from when we had to make it similar, when we actually did the calculation, the denominator is the same. It's only the number on the top that changes.